So I'm just going to review quickly the area of a parallelogram, and then we're going to see how that relates to the area of a trapezoid and how we get that formula. So just remember from, I did show this in a previous video that was optional above that was reviewing all this stuff. But the area of a parallelogram basically comes down, we want to find the area of the rectangle that you can create from this shape. And the way we create the shape, a rectangle shape out of here, is we take the triangle that we can create by creating a height line right here that's perpendicular to the base. And we basically cut off this little triangle here, slide it over, watch it, slide right over, and now we get a rectangle. So every parallelogram, which remember is this four-sided polygon with parallel sides here, and top and bottom are parallel, right? Then we can turn it into a rectangle. And rectangles have the easiest formula ever, which is great. The easy formula of every um, parallelogram, every rectangle is just remember um, base times height, right? So there we go. So we slide this over, and still the formula for a parallelogram is almost exactly the same as a rectangle. Now, the rectangle, the height is obvious, it's the side length. The only tricky thing in the parallelogram is that the height is sort of that perpendicular height hidden inside, but it's the same thing. So, real easy formula base times height. Here's the base length here, there's the height there. Okay? Now, how does this relate to a trapezoid? So here's a trapezoid, which again has parallel tops and bottoms. So B, length B here on this line segment and length A are different lengths, but they are still parallel, meaning they're never going to meet. If they go on forever, if those lines were extended forever, they would never touch each other. So in other words, also, they have this height between them that you can say the straight up and down right angle perpendicular height here, okay? Now, how do I turn this into a rectangle? That doesn't seem obvious at all. But I can turn it into a parallelogram, which is essentially a rectangle like we just saw. What do I do? Well, I take this here and I make a double of it. So see, this guy's the exact same thing. I'm just doubling it, and basically do a similar kind of move where I create a new shape by making double of my original shape. It's a little different than what we did before, but kind of a cool transfer. It's called a transformation, right? I've shown something here. And if I take the double of this guy and match it over here, I get a parallelogram. Okay, what's the area of a parallelogram? Well, height times this length right here. So what we're going to have to do then is basically say, well, our original shape was just this guy. So we only want that guy. That's the area we want. We want the space inside there. This guy is twice as big. So if we find the area of this guy, we just need half as much, or we need to divide by 2, and we'll have the area of this guy because it's just half as big. So where does this formula come from? Well, the area of this big guy is the height times this length here, or I guess you could call it this length down here too. Well, how long is this length here? Well, it's the length A, and this little piece here, if you notice, is just that piece here, B. So you just have to take the top and the bottom pieces here, the A and the B lengths, add those together, multiply that times the height, and that gives you this whole parallelogram's area. But I don't want the whole thing. I just want that piece, one of them. So what do? Divide by 2. So here is the formula for a trapezoid. I left it for last because it is kind of the most complicated one. But we'll practice that in IXL today. So I'm going to make a short video for how to do the IXL practice. It says 6th grade, but it's a 7th grade thing. And then you'll